Hello friends. In the previous video, we were introduced to the various machine learning algorithms and the respective libraries or frameworks that will be helpful for our for us to implement the machine learning algorithms. Okay, let's start with the simple machine learning algorithm under the supervised learning category, which is linear regression. So we will be learning about linear regression implementation using Python programming. Right. So when I say regression, that means what am I trying to do is you're trying to find the relationship that exists between dependent and independent variables. Right. So regression is a statistical model which helps me to identify the relationship between the dependent variable and independent variable. We have been studying this relationship in the form of a very familiar equation y is equal to mx plus c, where x is the independent variable and y is the dependent variable. So that means as the value of x varies, so its correspondence effect will be there on the value of y. So I hope you are familiar with this equation of y is equal to mx plus c and regression, right? So basically when you look into the internet, so you will find the application of linear regression by two approaches. One is through the library or scikit-learn method. Let me write that. So one approach is through scikit-learn, scikit, scikit-learn, using this approach or using the some statistical models, using some stats models, right? I will be using scikit-learn method in order to implement this linear regression. There are some differences between what is when I use scikit-learn and stat models, right? So when I do the model evaluation, scikit-learn will be able to give me in terms of accuracy, right? So, but in terms of stat models, if I use, I will have several other variables like p-value, f-test value, confidential interval value. All those are the outputs that I get when I use stats model, right? There is also some concept called as regularization, which in scikit-learn I'll be using that L2 kind of a regularization, but when I use stat models I'll not be using regularization, right? So what is the advantage why I'm going for scikit-learn is it is very easy to learn, very easy to use, right? And I will be able to model it better, right? And so that's why I'll be using scikit-learn. Okay, so let's learn how do we do that with the help of scikit-learn. So let's import what all libraries that we are already familiar with, right? So let's import pandas, pd, then let's import numpy, let's import numpy as np, then let's also import matplotlib. Let's plot the graph as well. Let's plot so matplotlib dot pyplot as plt. Okay, now I have defined all these things. Now let's define what is x and what is y. Okay, as I said, like regression means you're trying to understand the what kind of relationship that exists between the dependent variable and independent variable. So let me define how is the variation of dependent variable and how is the variation of independent variable. Okay, so let's try defining the array. So example x is equal to np dot array. So let me say 1, 5, some random numbers I'm giving, 13, 25, 33, 46. I've given 6 numbers, right? So I have to remember, I have to put here as reshape. I'll tell you why it is, why I'm doing reshape later. If I remove that, what is the kind of error that I get? I'll show you later, right? So right now put like -1 comma 1. So after this, I will define y. Okay, sorry. I will define y. Y is again np dot array. Okay, let me define values of output. So let me say 3, 6, 9, 12, 15, okay, 14, 8, 3 plus 3, 6, right? So now I am ready with my x and y data. So let me plot this. Okay, so let me do the first scatter plot. Plot dot scatter. If you are not aware like how to use the plotting, right? Please go back and get introduced to the matplotlib library videos which are there, right? So try understanding it and then come back to this video. Then I'll plot. I'll start giving x label. X label. I will say independent variable iv and plot dot y label. I will give it as dependent variable dv. Then I'll say plt dot show. So you'll get a graph like this. Okay, it's almost like, let me change some values. I'll make I'm rerunning it. Yeah, I've got a curve like this. Say you have already studied like if I do not want this dot, I want asterisk. Okay, how do I make changes? Right, all those things are dealt in the previous set of videos. If you are not aware, please go back and watch the videos. Okay, the description in the description you will see those links to those videos where you can go and study about how to change the color of this, how to change the x-axis, how to change the y-axis label, right? All those things you will study, right? So now my data is ready, right? X and Y, whose relationship I'm trying to find out. Now let me try do the regression, right? So how do I do that? So I'll be using, as I mentioned, I'll be using scikit-learn. So the short form is sklearn. Okay. So from this sklearn, I will take linear underscore model as it is already suggesting it. Okay. Then I'll be importing one of the that is linear regression is a module that I'll be importing. Linear regression, right? Please look at the spelling and the capital cases, right? So this is what I'm trying to import. Then what I do is I will define one of it. I will say simple linear regression. Okay, what is SLR standing for? Simple linear regressor. Okay, so which is equal to, I'm defining linear regression. I'm calling this function How do I call this function? This is the way you call a function, right? So I have defined SLR, simple linear regression, right? Now I will say regressor, sorry, not regressor. I will say SLR, SLR dot, okay. I'm training my model now. So what are the values that I have to pass? I have to pass X and Y, right? So once I am done with that, so I can use one more variable, prediction. So which is equal to, I will say SLR, simple linear regression, okay, dot predict value. What am I predicting over the value of X, right? So once this is done, I will be able to have some metric, right? So what are the usually how do you measure it? You either measure the absolute error or mean square error, right? So in order to know the definitions of what is mean square error and what is the meaning of absolute error, you may refer to the class notes, right? So and once you understand the what is mean square error and all, okay, so you can come back and say like you can define what is the mean square error, right? So from, if you do not know also, right, it is a metric in order to measure like how much is the predicted value and the uh, actual value, how much is the difference, right? So let me import one more module which is from sklearn again, metrics import. I'll be importing mean square error, right? So what is this mean squared error? Let me define it. I'll use the short form MSC. MSC is equal to mean squared error of, I'll copy the same thing, mean squared error. MSC is equal to, okay, the same thing, mean squared error. Okay, I am trying to say what is the mean squared error of, trying to calculate between Y and predicted value, right? So once I'm done, let me plot this. Plot plt dot plot. What am I plotting? So I will plot x comma predicted. I will say, let me put as color is equal to red. Then I will say marker. How do I want to mark? Marker is equal to asterisk mark. Right. So once I'm done with this, so let me print mean square error. What is that? I want to print. I want to print MSC value. Then I want to print even the y-intercept as well as the slope, right? So let me print that, print of intercept. Let me print y-intercept. So what is that value that I have is, I have regressor or SLR SLR dot intercept, then finally I'll print slope. What is that? SLR, simple linear regression dot coefficient, COEF. COEF underscore. Please don't forget this underscores after intercept and coefficient. Okay. Yeah, I have missed somewhere. Yeah, you can put this inside or you can avoid it. I have not put here at all. Invalid syntax. What is that I have missed out? I have missed out comma. Right, you can see the relationship. Okay, so and you have found like MSE mean square error is 11.24 and intercept is it is meeting at 5.5 and slope is 0.34. Okay, so if you put this into y is equal to mx plus c, okay, so the slope is m is equal to 0.34 and mx plus c, that intercept is 5.525. And so you will be working on with now error, okay, such that your g of or a cost function you are trying to reduce and arrive at a global minima point, right? So that is what the concept of gradient descent, right? So this is how you implement the linear regression, right? So what did I do in this entire program? First, I um, imported these pandas, numpy, and matplotlib, right? And then I have defined x and y some randomly, right? That you can read this from the Excel file as well. Okay, that is one of the tasks which you have to do it after this video. Next is I just plotted the graphs to find out, right, how is the scatter between x and y, dependent and independent variable. Then I have imported linear regression module. Right, I've defined SLR, so which is calling a function linear regression. Then I have trained my model here, which is like by using a fit x comma y. Then I have predicted the value of x. Then I have plotted the mean square error. And also I'll be able to arrive at the values of intercept and slope of this predicted line. Right. So this is how I do the linear regression. In the next video, we will see like how to, instead of giving your values like this, you can use a random module in order to generate this x and y values that we will try out. And one assignment is you have to try out reading these values from x and y from the Excel file. You have already used pandas, and in the previous set of videos where you have learned how to read each of the columns from the Excel file, right? I expect you to try out that, and I'll show you the some part of this video with respect to generation of random numbers for x and y. I will show in the next video, right? Sorry for this long video because I have to cover the entire linear regression in one video. So maybe rewatch the video again to understand the concept of implementing linear regression. Okay, see you in the next video. Thank you.